Okay, thank you very much. So my name is Giorgio. I'm the founder of Scality, and Lauren is one of our tech lead engineer. I want to thank js.la for having us and Headspace. I actually use the app and I love it, so there you go. So today we're going to talk about performance in JavaScript. I must confess that we've been using Node.js for only 1 year now. And so we learned a lot, so that's what we're going to share today. What we do is we are a distributed storage platform, object storage, for people who have a lot of data. So you need to have petabytes of storage to use us. So for example, some companies cannot use Amazon or S3 or the cloud, so they can use something like our technology, deploy their own servers in their data center and have their own storage pool. So typical customers are large internet service providers like Comcast or other companies like that. You need a ton of storage. So today we're going to talk about the team first. So the team event last year, fighting with a zombie was pretty cool. And so this team is a mix of veteran C developer, because we come from a C background. Everything we used to do was C, and if you didn't code in C, you were not a real developer. But we're changing, right? And the other half of the team is people coming from hackathon and from different backgrounds, like Lauren was a lawyer before she became a developer. And thanks to JavaScript, we were able to have everybody contribute pretty quickly and be part of the team. So what we developed is a clone of the Amazon S3 protocol. So to be able to store data using the same protocol as Amazon. So it's like you are using the public cloud with your own machines. And to be able to do that, there's the protocol stack itself. And that's an open source project that you can actually download. That's our S3 stack. Then we have made a metadata engine to be able to index content. So it's all done in JavaScript. And an authentication engine that we call Vault. So the open source S3 server, the architecture looks like this. So it's all done in JavaScript. When we started, we thought that we would do a lot of C code, a lot of modules. So we learned NaN and all these things. And in the end, we didn't have to do any. Actually, the performance we got after kind of optimizing was good enough without any C modules. So the S3 server allows you to go from so typically it's a Docker container that you start and you transform your laptop, a server, or anything into an object storage platform. So this is on GitHub. The URL is at the end of the talk. And we're happy to say that we reached 256,000 downloads in 6 months. So pretty happy about the success. So what have we learned trying to do our own S3 service? We're all about performance. Typically, people who use us has millions of users, and we need to be able to handle 1,000 of operations per second. And when we started, we were very far from 1,000 operations per second. And some very simple things were actually slowing us down. So today I'll talk about that. I will talk about debugging and what we had to do to debug some of the biggest issues. So the one thing that was slowing us down was logging. When you have a lot of parallel connections, you think about 10 or 1,000 of connections that do a lot of operations. Actually, logging was taking the most CPU time. So when we were doing profiling, it was actually all the stringifying and all the different parsing that was taking all the CPU. So we decided to do our own logging library that was minimizing the amount of transformation of objects into strings and trying to minimize even calling that.time was too time consuming. So we had to take it out of a process because this was slowing us down. So we spent a lot of time doing our own logs as minimal as possible and using ELK to do all the nice decoration, like going from a timestamp to an actual date, not in JavaScript because this was way too slow. So we had it done by ELK. Another thing that we did is try to not log too much unless we need to. So we developed this logging engine where basically as a connection comes in, we don't log anything that's verbose or debug until we have an error. So we kind of keep it in memory as an object, so that doesn't consume any resources, like a list. And when we actually get an error, we're going to dump the entire stack. So for most of the operation, there's not a lot of logs, and you don't consume too much CPU. When you get an issue on a connection, that's where we dump the logs, and you see all the details. So this makes a very, very big difference. So I don't know if you can read, but you can see that there's a connection coming to our S3 frontend that goes through multiple layers in the JavaScript microservices. And by typing just one ID, which is the ID of a connection, request ID at the beginning, I can trace everything among all the components in the platform. And if I get an error, all the components will get callbacks, and they all will dump the error stack. But I'm not having 1,000 lines of logs for no reason. So this had a big impact on performance. Then you kind of, it's different than when you code in C in terms of performance. You have to think hard about not using too many objects, not using some of the syntactic sugar, because it's going to hurt performance. So this is actually the cycle that we use is that we code something, we have a CI, the CI does a performance test. Based on that, we know what we should improve or if it's slower or faster than before. So one of the first things is we have a lot of small packets on the network for our metadata engine. And one of the issues is by default, the Nagel algorithm is on. So that means that it's actually anticipating that you're going to send more data before the packet is sent on the network. And so we had to disable this on our sockets because it was adding artificial latency, like in milliseconds. So we wanted to be much faster than that. So first thing was to disable the Nagel algorithm on every socket. Then it was about hunting all the CPU cloggers on the main loop. You know? So sometimes you call a function that looks very simple, but just going to compute a date, typically. And this actually stops the entire engine, and every other connection is waiting, right? So we had to take this out of the event loop, so chasing all the CPU consumers. Everything is buffers. We don't use, we use strings sometimes, but everything that is data is buffers. Because if you're using strings, you have no idea how many times it's converting from UTF-8 to whatever other encoding behind your back, and you don't. And this is nasty. So everything is buffers. Buffer concat is very slow if you don't have the size of the resulting buffer. So if you concatenate 10 buffers, and you know the length of each of them, you need to call buffer concat with the final length. Because if you don't do that, it has to do a lot of parsing to actually do the call. So this kind of small stuff add up pretty quickly. And after removing the obvious CPU users, buffer concat was something that we saw a lot. So some things that look like a macro optimization, but creating a date object each time you want to log something is very, very slow. So date.now is better. What's even better is not calling it at all. So having another process takes care of transforming a timestamp, Unix timestamp, a float into an actual date. Libraries, you know, JavaScript is great because there's so many packages you can use, but no, at the end, don't use them because you're going to call a package that's going to open 10 other packages, and we're going to do some kind of sometimes a check on the network itself. So you want to use as minimal dependencies as possible. All the developers wanted ES6 to start with, but Node wasn't ready yet. So we were using Babel to convert from ES5 to ES6. And Babel 5 was adding way too much unnecessary code, and that was slowing everything down. So we moved to Babel 6, and that really improved performance. It was just adding a ton of code that I don't know what it does, but it was consuming a lot of CPU, so I had to take it out. So at the end of the day, this is kind of the performance we get. So this is on one container. Okay. And on the left, it's a write operation, then read operation. So that's a standard benchmark from CoastBench, which is an S3 protocol benchmark. And I highlighted some of the interesting numbers in red. So you see for write, we got to 2,000 operations per second, which we were pretty happy with. So that's full S3 operation, so put of an object. On the left, you see the latency, and 126 milliseconds is actually pretty high. If you look at the read and the red square, it's 3,100 or 4,200 transactions per second, so pretty good number, but the latency is high as well. And so we kind of want to standardize on a 10 milliseconds latency. And if you look at the, oh, it's not on the slide. So each line is more concurrent connections. So it starts with write with only one connection, and that gives you 6.5 milliseconds. Yes. Yeah, and 150 operations per second. As you add clients, so it's doubling each time, so 2, 4, 8, 16, 32, 128. You see that you get more operations per second, but the latency increases as well. Right? So there's a trade-off to be made in terms of throughput and latency. And the latency is all CPU usage on the main loop. That's where it's coming from. So basically, on a performance number like this, we're going to go with the blue square, so the 10 milliseconds latency, which is what people expect as being our sizing metric. So even though we could do 2,000 operations per second, but latency is too high, so we size the system for 800 transactions per second. But we know that if there's a surge of traffic, we're going to be able to absorb it at the cost of latency, but at least the peaks of traffic will still go through the platform, and although the latency will be higher. Same for read operations. If you look at the blue square, it's 2,500 operations per second, so it's pretty cool, but only 6 milliseconds latency. So there's this trade-off. So each time we do network test with Node.js, as you add clients, you see that the latency goes up. So you need to decide on the trade-off. Talking about debugging. So we had a lot of socket issues. So things like you're using a stream, and the stream is using another stream, and they're all working perfectly, but the close call is not handled properly, or they don't really handle all the events. So you have some TCP connection that are still there, and you have to hunt for them. So one thing that we use is LLDB. It's pretty hard to compile. So we're pretty happy that we have Docker containers with a wide version of LLDB. And this allows you to dump on a live process the entire object, all the object that you have. So if you close all the connections and you still see a socket object, you can go into that object and understand why it's still open. So LLDB was very, very useful into debugging these corner cases. And we had a lot of them, because even though people think they understand streams, there's always something a little bit odd about them. And this allows us to kind of catch the last bugs. Some other tool that we use is strace. So we have this Node.js ticket that's open. It's not closed yet. It's been a long time. But we had a system where some socket was always going in and out of EPOR. I don't know if you're familiar, but Node was thinking that there was some data to read, but there was nothing to read. So that made it go in and out of the main loop, and it consumed all the CPU on the machine. And using strace, which is a standard system core, not related to Node, but it's very useful in that case, we're able to know which sockets are open and which event they're seeing. And there you see that socket number 6 is actually getting an EPOL out event in a loop from the strace output. Then you can go to LLDB and dump whatever's happening to socket number 6. So this kind of tools allows us to debug and zoom very, very quickly. So this is kind of the talk about performance and tools. And now it's up to Lauren to talk about Nifty node tools. Oh, no, you don't need it.
Can you hear me?
I think so, yeah.
Okay, excellent. So in getting performance, Node is amazing because it has a really strong core and it has tons of tools. Okay, so in the core, one of the most important things for performance is using streams properly. Because why would you hold data in memory or anywhere when you can manipulate a stream? So especially in our case where we're taking in tons of requests of data and sending out data and getting data from our different components, as much as we could use streams as possible, you're gonna up the performance. And actually, it's actually a fun part of Node Core, I think at least, to work with, because if you go look at, so the basics in Node Core, you have readable streams, writable streams off the shelf. And then they have something called a duplex stream, which puts readable streams and writable streams together. And then they have something that's a transform stream, which basically I have my stream of data coming in. I can do whatever I want to it. Like if it's a letter, I can advance every letter by one, whatever your transform function does, and then write it out to the other side. And if you actually look at the implementation in the Node source code of transform streams, I think it's the best way to see like, what's going on with streams, because you can see, oh look, they just put a dummy function in like the transform function, and you can put anything you want to do there. So if you go, so one simple example, I think it's like the casebook example of how people use it is if you need to like hash a stream of data, like some data coming in, instead of holding all that data in memory, you can just like, as you're streaming it, collect it and then hash it at the end when it's done. You could also do weird, funky things like we have in S3, they have multi-part uploads. So that means when you're putting a really big piece of data, you can put like parts one at a time. And we're storing those separately. So if someone goes and gets that data, we have to go fetch all these parts. And through using streams, we could like create a stream that holds a bunch in memory so that it's ready to write out to the other side as soon as the requester is ready for it. Then also there's the cluster module. So you know, JavaScript single threaded, so you're limited to one process, but with the cluster module, you can just spin up workers and they're each independent. One could hit an error, insertion error and die, and just a new one will come back up. It won't hurt the other ones, and it can really just multiply your performance. And then on performance, there's also the team performance. What's great about Node is you can get a team going and working and producing code really quickly. It's amazing like how fast you can get features out. And one of the ways that we found that we were able to get coding really quickly in a synchronized manner, even though we had a part of our team speaking French in France, and the rest of the team in San Francisco, was having just a style guide that we had to all conform with, because otherwise we'd be arguing all the time, even more than we did. And then, as Giorgio mentioned, Babel was great to get going with the ES6 stuff, but I would recommend getting rid of it as soon as you can. And with Node 6, all we're using left in Babel is imports, so it's not impacting performance anymore because it's just its startup. And then Commander, if you haven't played with it, it's a cool way to have like a CLI tool in minutes. And then I think there's a big always debate: do you use promises, do you use async, what do you use? And we've been using just straight callbacks and async, because the performance is better, and errors can just get lost with promises and you don't have that problem. Our metadata backend is actually using LLDB, and Node being the amazing community that it is, there's of course a LLDB wrapper, so you can just use whatever you want. To up your performance, caching always comes into play, and we've played with both Memcached and Redis, using Redis as in production, and it's been great. As Giorgio was saying, though, you don't want to get too heavy on using modules. Like you could use an XML parser that's off the shelf, and that's helpful. But then if you actually need to create XML, it's actually just easier to concatenate your own strings, and you're not going to end up using someone's code that you don't trust. We also use the profiler, obviously, to get our performance. And then we actually recently moved to Node 6, and if you really wanted to get into the nitty-gritty of the Node 6 benefits, the guy who did the Bluebird library has an optimization killers page, and the cross-out lines are things that are no longer problems in Node 6, but that were prior. So like we had someone on our team that would like scream every time you used a try-catch statement. And they probably still will, but at least we can say, hey, it's crossed out on the official page. So it's demo time, so you can see that we actually have built something after all this talking. So let me pull this up. Okay. Heroku actually has a sample app for what you would use with Node to talk to S3. So if it's good enough for Heroku, it's good enough for me to be for a demo. And what it looks like it's just a simple like web app where you have assets that you want to call and store somewhere, so you're storing them on S3. So the code, which I just forked on GitHub, it's a really simple web app. All I had to do to point it at our S3, Scality S3 versus AWS, is point to localhost 8000, and I can run my own S3 on localhost 8000, and then this app will hit it there. So to run that app, all I have to do is start this command, giving it the app. With Scality S3 off the shelf, you have an account set up with the really awesome password and access key 1 and very secret key 1. So that's, if you go use the Docker, you can obviously change these, but if you just want to like play and do testing against an S3, those are ready for you, so you just set those, and then I'm gonna be pointing my app at a bucket called js.la. So I have that going, and then I'm going to start my very own S3 magically. And then I don't know if you've ever used this GUI called CyberDuck. It's really just a client you can use with S3. So I'm going to create a bucket, which they call a folder, called js.la. So there I have my bucket. It's empty. And one thing I have to do is, because the calls to put these assets are happening on the front end in this app, I need to have a CORS configuration. And then all I'm putting is a CORS rule to my bucket that just says allow anything. So let me do that. Great, so I'm set up with CORS. Now I can go and interact with my web app just like I'm a user. So I can create my avatar. And there you go. What is he thinking about? He's thinking, when is she going to stop talking so I can have another beer? But here, so you see in your bucket now I have this picture, and if I was unsatisfied, I can go ahead and have a group of otters because it's cuter than just one. And then back in our bucket, we will see that we have a group. So that's how it works. We actually just, in the open source one, we have bucket website, we have CORS, we just release versionings. We have a pretty robust set of the S3 API. So that's really all. Where did I put this? That's not what I wanted. So things that we are thinking about doing even further on the API is to add Lambda functions like in Amazon, so you can put an object only if it's raining outside or whatever you want to do. And then we actually recently have a blog post about you can use the S3 with Docker Swarm, so you could have multiple instances running and have the same shared storage. And then we're also working on having multiple backends. Right now, you actually can have multiple backends. You can be using a file and memory backend and a memory backend. And to be coming very shortly would be you could actually put to real Amazon through this interface and your own file backend. So if there was some use case where you wanted to be interacting with Amazon with the same application and your own hard drive, you could do that. And then if you have any ideas of how you think that S3 could be expanded, what you would want, come talk to us. We'd love to get the feedback. And that's some of the ways to find out more about the S3 server and our contact info.
That was a great talk.
Oops.
It's really good. I have to say, like, I've had some really janky Node.js applications that I've written. Now I know it's all because of my console logs that I throw everywhere.
Exactly.
These more streams. I love streams, actually. I don't know if you guys have got to play with them. Actually, we do have an event called Node School that we host every month. And we do have a package that you can learn. It's called Stream Adventures, which will teach you all about streams. But actually, we're going to do some questions if you guys have time for it.
Yeah, that'd be great. And just to
questions? Go ahead.
Giorgio, you mentioned a lot of like the little tips and tricks and efficiencies that you can use. Are those just things that people on your team already knew, or is there some place that we can find like different? Because these seem like pretty obscure, like little tips.
I think we discovered along the way it was a lot of trial and error. It makes sense to put them online at some point, but yeah, we haven't done it yet. But it was a lot of trial and errors.
Right.
And sometimes it's not obvious. You think that this is going to be slow, it's not, and what you think is fast is slow. So it's not obvious.
But the buffer concat thing with the length is actually in the node docs, but you ignore it, and then you're like, oh.
David.
That's awesome that you're using Level. We use it pretty intensively. Have you run into any issues, things you don't like about it? Are you using any of the crazy forks?
So at the beginning, we did, I don't know what happened. We use a ton of different forks, like LLDB, but they all, it's either you get good latency or a lot of operations per second, but you cannot get all at the same time. And all the forks change where you want to put your balance. And LLDB gives you a lot of operations per second, bad latency on read, for example. And at the end of the day, the standard LLDB for us is the most kind of balanced in terms of the ratios. And we were very worried about the the compaction. It's actually not impacting us at all.
All right, we'll take one more.
So right now your S3 is like pretty much an exact copy of Amazon's S3?
We wish it would be exact.
Do you have plans in the future to try to make it more and add functionality that S3 doesn't offer?
So this is Paul, is our product manager. He wished that we were so popular that we could influence Amazon and add our own features and have them follow. So, but that's a dream. But
the multiple locations is added on.
Okay.
Oh, yeah,
So
that's
they're
true.
having multiple backends. They don't do that. They require you to actually store the stuff there.
Yeah.
That's what I was wondering though.
Oh,
if you want to have something that Amazon would then want to take and add to theirs.
That'd be pretty cool. So, as Lauren said, we have multiple backends. We're going to add Azure as a backend, Microsoft Cloud Storage, as well as Google Cloud Compute. So, but we'll teach them.
Awesome.